CIT 1122, Module 3, VLANs. In this section, we have a few different parts. The overview of what a VLAN is, how to set up VLANs in multi-switched environments, how to configure a VLAN, VLAN trunking, and the protocol that manages the trunks, dynamic trunking protocol, DTP. Let's take a look at the overview of VLANs first and get into a nice slide. It's a nice diagram here. We've got on the left-hand side, we've got a bunch of PCs. There's 6 and 9 PCs. Those PCs are connected to 3 different switches, which go to another switch, which goes to a router. And what they're pointing to here is this, is that each one of the PCs that's connected to each one of the switches is actually in a different VLAN. So if you look at that top switch there, we take a quick look at that switch, and we look at what's coming off of that. Obviously, this first PC here is connected to an interface, and the second PC is connected to an interface on that switch, and the third PC is connected to an interface on that switch. And yet, those 3 devices and those 3 interfaces are not on the same network, and they are not in the same VLAN. So one of the first things I want to bring out about VLANs is this, is that a VLAN, if you start considering a VLAN, one VLAN is going to be its own broadcast domain. Okay, so one VLAN equals one broadcast domain. And what I mean by that is this, is that by default, all of the ports on a switch are configured in the same broadcast domain, right? So if you had a switch with 24 ports and you sent a broadcast message out, one of those 24 ports, the other 23 ports are going to receive that broadcast message. Now, what if I told you this? We want to have more than one network, or we want to suppress some of those broadcast messages. So maybe we want to do this. We'll take ports 1 through 8 and we'll configure them as a port group, and then we'll send a broadcast message out interface 1. It'll now go to interfaces 2 through 8, but it won't go to 9 through 24. So we can actually block off those ports and really make them their own broadcast domain. Now, when we set something up in its own broadcast domain, generally we also want to set it up within its own subnet also. So one VLAN, one broadcast domain is going to be one subnet, because if you try to send traffic across a device to another device that's in a different network, you have to go through a router, right? If I have 2 devices connected to a switch, and these 2 devices are in different subnets, and I try to send a message directly from one to the other, it's going to fail. So it's pointless to put 2 devices on the same switch that are in different networks. So what we're going to do is this, is we're going to efficiently use the ports on our switch. So the whole idea of this is we can take a switch that was one broadcast domain, and we can carve it up into as many broadcast domains as we want based on the configuration of the actual port/interfaces on the front of the device. So we're going to configure those port/interfaces, and the name that we're going to give those is called a VLAN. And we're going to give our VLAN numbers, and that's going to dictate the size of that particular broadcast domain. Let's take a look at the next slide. Oops. The next slide looks like this. It says the benefits of VLANs are as follows. We can shrink down the size of broadcast domains by making multiple VLANs. That's good. We can improve security for our company by creating multiple networks, right? So in this case, if you look at the picture we have here, they've got 3 VLANs, one for faculty, one for students, and one for guests. Okay, great. If we aren't going to create VLANs, then anywhere we want to have a connection to faculty or student or a guest network, we would have to have an open port on a switch that's specifically for that particular subnet, for that particular network. And that's going to cost us a lot of money, because now we got to buy 3 times as many switches as we would have otherwise. If we can efficiently use the ports and switches that we have, we can assign some of the ports to faculty, some of them to student, and some of them to guest, and we can just use one switch to make that happen. So it's going to save us a little bit of money. It's also, and that goes into improved IT efficiency in line 3 there, but it's also going to improve the security, because if I now want to send information from faculty to students, if they were in the same subnet, they might be able to communicate directly with each other. But at this point, if I want to go from faculty and I want to go to student, no problem. That's got to go up. It's got to go into the router, and the router's got to send it back. Now, here's the advantage of that. The router is going to forward the traffic based on the subnet, but I can create what are called access control lists here. I'm going to write ACLs right here. And those access control lists can control the traffic between the faculty computers and the student computers. So the faculty computers might be able to send certain types of files, but they won't be able to send other types of traffic from one network to another one. That's going to really improve the security of our system. We talked about reduced cost. It is going to create better performance as well because we're going to have less broadcast messages that are going to be passing along. And it can make your network management simpler. There isn't a network that I've worked on in the last several years, even for really small companies, that don't have multiple subnets, mainly because this. Even if you said, my business doesn't matter, I trust everybody that works here, we're all together in the same network, that seems great. So we're all going to share the same printers, we're all going to do the same stuff, we're all going to be in the same subnet. What about the wireless? What about the wireless guests that come in and want to use your wireless network while they're there? Do you want them to have access? Do you want to allow anyone that sits in the parking lot that can Wi-Fi in, if they guess your password, access to all of your company files and your records and your QuickBooks and uh, your personnel files and everything about your business? Of course you don't. Of course you don't. So what you're going to do is you're going to take those public Wi-Fi networks, you're going to put them on their own VLAN. And you're going to take, in most cases, you're going to take other things that use your network and you're going to put them in their own VLAN. So for instance, like a security camera system, you want to watch it on your phone. Okay, no problem. It's got to join the network. Do you want that insecure DVR or NVR maybe launching an attack on the rest of the materials on your system? Of course not. Put it in its own VLAN. What about your burglar alarm system? Put it on its own VLAN. What about the HR records? Do you want those records on the same system? No, of course not. What about the management of your devices on the system? Wouldn't you want your own network to manage those devices, to have the security and know that only these computers within our system can go in and manage the switches excuse me, and the routers that you have available? Of course you do. So VLANs are a thing, and there's only a couple of VLAN deniers out there that I know. But for the most part, people are not VLAN deniers. They're VLAN acceptors, and they do agree that it will be an efficient use of your network resource for all those reasons that we just listed there. Now, a couple things about VLANs in general. We've been using switches in the classroom all the way through 1121 and now partly through 1122. And we found that if we just plug into a switch, it will allow data on the same network to talk to another device that's on that same network. Now, here's the thing. By default, switches are set up without any port groups being created. There are no VLANs by default. So all of the ports on a given switch, on a Cisco switch, are in what's called VLAN 1. And it is the default VLAN, and the default VLAN is also at this point known as the native VLAN. We'll get into like why it's the native VLAN later, but VLAN 1 is the default VLAN that all the ports happen to fall into. Okay? It's also the default management VLAN. So if we were going to manage the switch, we would do it through VLAN 1. And you remember in your labs, you guys typed in like INT VLAN 1, enter IP address, blah, 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 100 times in 1121. You're not going to do that much more here. So we're going to set the IP addresses on our switches to a VLAN that is known as the management VLAN, where only devices on that network will be allowed to access the CLI remotely through SSH. So you'll only be able to SSH through an interface that has an SVI or a switched virtual interface. And that IP address will be on the network that's associated with the management VLAN that you create. So you're going to create a management VLAN. More on that in the next slide, which is in here. So there are data VLANs where we're going to pass traffic, email, web traffic, so on and so forth. VLAN 1 is the default VLAN for this, but we're going to generally take it off of VLAN 1 because when we get into trunking and native VLANs, there's a little bit of some weirdness that goes along with that. So just be aware of that. So there are data VLANs that we're going to use just for regular production work. There's also the native VLAN, and we throw this out here right now a little bit, but we really aren't going to really talk about native VLANs until we get into the trunking section, like 2 sections away. So know that there is something called a native VLAN. It's used with trunks. And the idea is that the way trunking works is this, is I've got a switch that's connected to another switch. And each one of those switches has 5 VLANs that they're using. Well, if I have 5 different VLANs on each one of these switches, I now have to take an interface between each switch for each VLAN and assign it to that VLAN in order for all 5 of those VLANs to communicate. So rather than doing that, what we're going to do is this, is we're going to say I got 5 VLANs on switch A and 5 VLANs on switch B, and they're the same 5 VLANs. And so what I'm going to do is I'm not going to create 5 links between the switches, but I'm going to create 1 link. And when I send traffic from the one switch to the other switch, I will add what's called a tag that tells the receiving switch which VLAN this information should be sent to. So what ports should be used when it gets to the other side. We do a whole bunch. I did a whole bunch of videos for packet tracers that you can watch, and you can look at those and watch those, and we'll get into those more. We also get into it more in like 2 sections away from now. Okay, so that's a little bit about native VLANs, 802.1q trunking, and frame tagging. And then the final piece there, we actually just talked about this, the management VLAN. If you're going to SSH into a switch and configure it, you want to make sure that that is a secure device. So the best practices are that you create a network just for devices that'll be used for network management tools. So not only SSHing into switches, but if you're going to allow Wireshark on your system, you'll allow it to the management network. Other tools that you may want to utilize, you would just utilize those on the management VLAN, not on the production networks. Okay. So keep that in mind. The 4th type of VLAN that they didn't put on the last slide, that they did put on this slide, is called a voice VLAN. A voice VLAN is kind of a special VLAN, and the voice VLAN is special because it is going to do something that your regular VLANs don't normally deal with, which is you can set a prioritization value in the frame tag. And that is called QoS or also CoS, and you can prioritize the information to your VoIP phones for your voice. So essentially, when we start talking about different kinds of devices, which we're going to get into in just a second, there are access devices, which are end devices, and then there are trunked devices, which are intermediary devices. So I would trunk information usually from switch to switch, which means I have to identify which VLAN the traffic is from. But to an access device, I don't have to identify what VLAN it's on, except for in one special circumstance, when there's a phone in between your computer and your switch, which is a very common way of setting up networks these days. So you can see in the picture here, we've got switch 3, and switch 3 has got information that it's going to send out interface 18 to a phone, and it's also going to send information out to a PC. Now, here's the thing. The PC is on the student VLAN. Okay, great. And the phone is actually on a voice VLAN with a different VLAN number, and they have to essentially trunk that traffic across that interface to get to the phone. So we have to identify what information is for the phone, what information is for the PC, and you set that up with what's called the voice VLAN, and you'll usually have a quality of service line that'll go with that. Once again, do all the packet tracers. There's 6 of them with this particular module, and you will see there is 2 examples of setting up the voice VLANs in the labs that you're going to work on. And this last part just talks about who's hearing broadcast. I feel like we're okay on this piece right now. This is also borne out explicitly in the instructional videos for the labs. So once again, 1 VLAN equals 1 broadcast domain equals 1 subnet. That's how we're going to want to run that.